data science challenge where we'll go over transactions and concurrency control. And this is basically two critical concepts for ensuring data integrity and consistency in multi-user database environments. So we'll look at an overview, transactions, property of transactions, asset transaction commands, concurrency control, isolation levels, locking mechanisms, best practices, a hands-on challenge and exercise, and a Day19 summary. So what is a transaction? It's a sequence of one or more SQL operations executed as a single logical unit of work. Concurrency control ensures that multiple users can access the database simultaneously without conflicts or data inconsistencies. Together, these concepts form the foundation for reliable database operations. So in transactions, we have properties of transactions, which is ACID. So transactions adhere to the following properties. We have atomicity, which is all operations in a transaction succeed or fail as a unit. Consistency, transactions bring the database from one valid state to another. Isolation, transactions are independent of one another. Durability, once a transaction is committed, its changes persist even in the event of a system failure. And we have transaction commands, begin, which starts a transaction, commit, which saves all changes made in the transaction, rollback, which undoes all changes made in the transaction, save point, which creates a point within a transaction to which you can roll back. So we have some examples here. We have begin, which updates accounts, sets a balance equal to balance minus 500. Where the account ID is 1, it updates the account set balance equal to balance plus 500 where the account ID is 2, and then it's a commit. This is pretty interesting, similar to how the GitHub commands are, and you have two IDs, 1 and 2, one where there's a balance minus 500 and a balance plus 500. Okay, so then we have concurrency control, which is isolation levels. So SQL defines 4 isolation levels to control the visibility of changes between transactions. There's read uncommitted, where transactions can see uncommitted changes from other transactions. Read committed, which transactions see only committed changes from other transactions. Repeatable read, which ensures consistent reads during a transaction. Serializable, which provides the highest level of isolation by fully locking the data. So you can set an isolation level, you set transaction isolation level serializable, you begin, and then you put transaction code and you commit. Then you have locking mechanisms, which is a shared lock, allows multiple transactions to read a resource but not modify it. Exclusive lock, which allows only one transaction to modify a resource while preventing others from accessing it. Deadlock, which occurs when 2 or more transactions block each other. We have best practices, which is minimizing lock time, keep transactions short to avoid locking resources for extended periods. Use proper isolation levels, so choose isolation levels based on application needs. Avoid deadlocks, so it's like ensure transactions access resources in a consistent order. Test thoroughly, so simulate concurrent transactions to detect potential conflicts. And there's a hands-on challenge, so write a transaction to transfer funds between accounts with proper error handling. Test different isolation levels and observe their impact on concurrent transactions. Create a scenario where deadlocks occur and resolve them. Implement a transaction with multiple save points and rollbacks. And there's 2 exercises here. So exercise 1 says write a transaction to update stock levels and commit the changes. Create a save point during a transaction, roll back to it. Demonstrate the use of the rollback command in case of an error. And we have level 2, which is simulating concurrent transactions accessing the same resource with different isolation levels. Writing a query to detect and resolve a deadlock scenario, implementing a series of transactions to maintain a consistent state in a sales database. Then we have the Day19 summary. So we covered transactions and concurrency control, exploring their role in maintaining database integrity and handling multi-user environments. And with this knowledge, you can create robust, error-resilient SQL applications. So we'll go on to Day 20, which is the advanced SQL practice and quizzes according to this course. And it's all about applying what was learned so far through practice and a quiz to test skills. So let's sharpen the SQL abilities with real-world scenarios. So the practice scenarios are aggregates and joins, CTEs and Windows functions, and subqueries and set operations. So this will basically reinforce understanding of key SQL concepts, including aggregate functions and joins, copy and table expressions, Windows functions and their applications, subqueries and set operations. Okay, so practice scenarios. Write a query to calculate the total sales revenue for each product category in the last year, including the category name and total revenue. Use joins and aggregate functions. So it says total sales revenue. So there's probably a summing of the amount as sales for each product category. That's saying there's a products table. There's probably a join between sales and products table. Then it says in the last year. So you're gonna have to specify sales date. There's a category name which needs to be grouped and a total revenue which also needs to be grouped or ordered by, and then joins and aggregate functions. So that's the general kind of hypothesis. And it says you'll need to join the products table with the sales table and group by category. So what they said was select P dot category name, so this is probably from the product table, sum S dot amount, which is from the sales table, as total revenue. So we're getting category name and the total sum from products, and then join sales S on P dot product ID with S dot product ID. So product ID is the primary key here, and it's joined on both, where S dot sales date is greater than this amount, grouped by P dot category name, and then ordered by total revenue descending. Okay, so from highest to lowest. CTEs in Windows function. So it says use a CTE to create a temporary result of customers who made purchases in the last month. So the last month needs to be specified, a result set of customers who made purchases. So you need to see the amount that customers have, and then use a Windows function to rank these customers by total spend. So it says combine CTEs and rank. I forgot what rank does, but I'll cross-reference with another video. So it says with recent purchases. So we saw this in the advanced functions video last time. With recent purchases as, select customer ID, sum the amount is total spent from sales, where the sales date is greater than this amount, and then group by the customer ID. And it says select customer ID, total spent, rank over, so that's different than what's within the subquery, order by total spent descending as rank, and then from recent purchases. Okay, so I'm not really sure how these two work together, but that's what they're asking with the window function at CT, so I guess we'll go with it. Subqueries and set operations, find customers who purchase from both the electronics and furniture categories. Use intersect between two subqueries. So select customer ID from sales, or product ID is in the select product ID from products, where category name is electronics. So let's specify the electronics, and then it's doing an intersection with furniture. So intersect select customer ID from sales, where product ID is in select product ID from products. Your category name is furniture. Okay, which SQL clause is used to define a common table expression? I think it's probably with. What does a row number function do? Counts the number of rows in a table, assigns the sequential number, sorts rows. I think it might count the number of rows in the table. And then query challenges. Write a query using recursive CTE to calculate the factorial of 5. Use a Windows function to find the secondized total sales amount in the sales table. Combine multiple CTEs to identify top performing products. And then this was basically consolidating the SQL knowledge with practical exercises and quizzes from advanced aggregates to recursive CTEs. And you've looked at scenarios that prepare for real world database challenges. And yeah, thanks for listening.